This is going to be my demo for the first and second milestone. So first required feature was the X-Audio 2 voices. They're encapsulated inside this voice class that's protected by handles. The handles are kind of a protection mechanism for multi-threading. In this case, they're essentially managed through this handle manager, and this guy acts by validating handles, acquiring them, and invalidating them. The protection happens through the use of mutexes. And so it's kind of just kind of built-in handle manager we were given to use as protection for all our resources. So the voice is created, it calls the audio engine to get the X-Audio interface. The X-Audio engine has a create method where it initializes the X-Audio interface and creates a mastering voice. And that's where a lot of the functionality of the occurs. So the volume can set the volume of the source voice, so every voice has its own X-Audio 2 source voice. So it can set the volume, set the pitch, and then the pan is a bit more complex, but it just creates this output matrix and then sets the source voice values. So for the wave loading, waves loaded, it's taken a file name, this load function. This load function calls this X-Audio 2, or this audio loader, almost like a static method. It just takes in the file name and it reads the file data, gets all the necessary header information as well as the data buffer. And then it has a reference to this output structure that the file, the wave class called. And from this data, I guess this data is just kind of kept in storage here so that sounds and voices can use it to create sounds. And these are managed through wave managers. I should say the voices also have voice managers that are used to call and manage the resources there. And the voices, the hierarchy is that there's playlists that handle the instancing. So playlist has a voice, and then an audio sound contains a playlist, and then the unique sound instance that occurs on the game has an audio sound. So that's kind of how the instancing relationship works. So you can have multiple of the same sounds playing. For our next requirement for the stitching, the voice has a special create function right here that takes in multiple waves, a wave name array pointer, and then the number that occur. How this works is that creates its own initial voice, and then for every subsequent array name in here, it's going to create another voice as a single voice in this individual constructor. And then this voice is a callback, the X-Audio 2 callback that you can create when you create the function here. This X-Audio function that takes the callback. The overridden pointer class, or the derived callback class, it has a next voice pointer. So you just set it here, and then you just switch this next voice, previous one, and then you keep kind of appending the next voice. So, and then this does the seamless transitions when this onBuffer, I guess actually the onStreamEnd function is called, and then it's going to check if I have a next voice. If I do, I'm going to set its attributes to mine, and I'm just going to start it up. And that's basically how the voice works to do the seamless transitions between the stitching. So the next feature was the priority table. So priority table, it exists as a handle protected singleton, and it has the add or move methods. So, and this guy gets called by the sounds, the game sound, when it gets started and stopped. So when it gets started, it's going to attempt to add itself to the priority table, and if it successfully added itself, meaning it had a low enough priority as well as a low enough start time by this starting here, then it will go into this guy and it'll try to meet some conditions. One is if it's lower priority, it will insert into here, or in other cases that because this list is sorted properly, you can just check if it was before the maximum entry count, and it'll just insert itself. The other case is that if it's somewhere where it has a lower, if all the priorities are the same, like in the last entry, but this guy's got a lower starting time than any other value of the same priority, it will replace it. And any sounds that are going to be replaced, they have this stop method call that's going to stop the sound, so then it will only keep track of the 6 required ones that the maximum amount we can have. Okay, and then the next feature was the user callbacks. So essentially, sound has a function called set user callback, and this function will offload its functionality to a command. And eventually this command is going to happen in the audio thread, and it's going to set the callback for the sound, for the audio sound I should say. It's going to get offset into this audio sound. And then when this when a sound is stopped, it's called, it's going to execute the user callback, and in this case this is a simple one that prints out the information. So this can happen inside the xaudio2 voice callback when streamEnd is called. This audio cue command soundEnd gets triggered, and when it gets executed it's going to call stop, and stop is going to call a stop sound command, and the stop sound command is going to execute it, and it's going to stop the audio sound, and then the callback will get executed. And the last feature was the asynchronous file loading. So how this works is the wave manager, when a file is added, instead of loading it in this function, a file queue command is sent to the load wave with a load wave command. And this guy is gonna, when it gets executed in a file thread, it's gonna check if there's a callback. It's gonna execute it if there is, but first and foremost, it's gonna load the wave. So then that's how that's gonna work. And then how the sounds know to start only after the wave has been loaded is that the sound, I have all these commands that these method sound commands are what all these guys derive from. And this guy, he can only execute himself and remove himself if an audio sound exists. And an audio sound will only exist if these create commands, so these create simple sound commands and create stitch sound, these derive from this create sound command. And this guy can only execute if all of the waves that are associated with the sound have been loaded. Otherwise they're going to remain inside my queue, and they're going to stay there until the waves are loaded. Okay, and so yeah, all these are managed to managers. And so let me start the demo for the required features. It's the first demo is playing right here, started by these keyboard inputs. It's going to be a short break until this guy executes, but I've just been showing off. All these guys execute as these script methods on the game thread, and these scripts call the sound methods, and as I was saying, these sound methods then go and execute on the audio thread through all these different commands. Let me start the stitching demo. Okay, let me start the priority demo. It's going to print out the table with all these different sound starting points. Okay, and at the end you can see that the most of the table is sorted and the newest, most frequent ones are playing. And then the next demo is the user callback. So this user callback script with this pan script combined, it's going to set the callback on the, or call the commands on the game thread, and then it'll get pumped to the audio thread inside the sound. Okay, so it was printing out all these callbacks, string prints at the end of it. And the last demo is going to load this, these waves, and then there's an optional parameter inside the method that's going to take a callback. And so we're just going to print out the data when this is loaded asynchronously on the file thread. Okay, and those are all the demos illustrating all the required features.